It's time to add the PID and the Kalman filter.
Alright, components you got to set up are your steering and your H-bridge components, your RC control for turning and speed, your action button setup, your PID controller, and then your ADXL335 and your Kalman filter. These are feedback examples where the gathering of the three elements and then the math is applied and then they're summed back together. Now the feedback loop comes into play from the analog chip, which uses a piezo gravimetric measurement. This is why this is called a feedback loop, because it uses the output as the input for the math. The Kalman filter is a type of low-level pass filter. It lets more or less of the shorter duration high-level noise affect the math of the longer duration low-level noise in the data feed. This is fed into the motors, which affects the gyroscope's output, thus returning the feed. I'll explain it another way. Alright, so go ahead and get Visuino set up with your gyro and the Kalman filter. I used all stock values here, so there will be no confusion when you are setting yours up, so you know you have the same input output as I do. This video up there shows the three different movement type samples that are used. One is with the bottom stationary and the head tilting forward backward. The second one is the bottom and the top moving in the same direction at the same time, same speed. And then the top is stationary with the wheels moving back and forth, which is what an inverted robot, balancing robot, does. In that wave, you can clearly see the rough edges of the blue input as compared to the red output. You can think of it like a wave in the water, actually. No matter how hard you hit the water, it will always be forced into a smooth wave-like event. Probably don't understand it yet. Let's look at the graph closer. So, the purple line indicates a rough center upright position. And then about midway, you can clearly see a large increase in the output, or the red line with the little movement of the input. This shows the ROC interaction. Large ROC increases the power output that is delivered with less impact from the sudden sharp movements of the blue raw input. So you can see how the Kalman filter doesn't use any of the sudden sharp movements from the input if the gyro is telling it to hurry the fuck up, we have to go this direction. So I guess that I hope this helped you to figure out the Kalman filter at least a little bit so far. You basically have to understand that no matter what, if the gyro or accelerometer is telling it, hey, you got to go this direction and you got to get there quick, it's not going to pay any attention to those sudden little up and down sharp movements, like it's running over a twig or a cat or a dog or hitting a wall or whatever. You know, it's all about leveling out the feed and creating a smooth wave out of the jagged step of the readings from the actual gyro. So it reads it in a time cycle. And what the Kalman filter helps do is to smooth out the feed and the responses during that time cycle in the reads. Because they can vary differently, you know, and you might only be talking about 100 nanoseconds, which is a tenth of a millisecond or something like that. But it does make a difference, and it does show on that input without the high filtering, the high pass filtering for your sharp movements, sharp sudden movements or vibrations. And we're gonna start on part 5, which is the PID controller. And PID controller If you don't understand the Kalman filter, then the PID controller is just gonna turn your mind to mush. It's gonna literally make you think like you're a toad. So if you're having a hard time understanding the PID, you might want to rewatch the video and do a little bit more reading up on it and play with the values, your process noise values, and your your feedback process noise and things like that. Change those values a little bit. Every robot changes with how it acts and what it does. So you really have to pay attention to what you're trying to do and what you're trying to accomplish. Now you don't consider your PID tunings at all when you're doing your Kalman filter. All you're trying to do is get a good, stable, smooth output that the PID controller can use. That's the whole objective of the Kalman filter, is to get a nice, even, smooth signal that the pig controller can say, hey, I got to turn it this way or turn it that way. And then the Kalman filter kicks back in and says, oh, it jerked that way a little bit. Now I got to change it. So they both kind of work hand in hand, but they also work independently. So, it is a really, really tough job to get these tuned in. And I'm going to move along to part 5. I hope you enjoyed it. Hope you learned something. And I hope you can use this video while you're building your own balancing Arduino robot with Visuino. Because Visuino is simplicity at its finest when it comes to programming the Arduino and not having to learn a new programming language, which is awesome. So, peace.